morning everyone. So in continuation with last class, let us see. So we have discussed last class some name node safe mode and some features of the like HDFS how to check. Okay, before going to this, so we'll have a 1x Hadoop 1x cluster installation. Okay, so I have cloned in the last class with master, and I am going to change the IP addresses of the master. Now let us see, and meantime let me open some document for Hadoop installation. Okay, so I have opened Hadoop 1x sudo mode installation document. Okay, let us keep it here. Then let us start the machine. So I'm going to start the Linux machine, virtual machine, Oracle virtual machine box. The box name is master, and it is going to start. Just let us start. I just cloned it from slave. That's what you can see, it's slave login. So I'm just logging with the root, some password. Okay, so now if I see IP if config, it is showing some IP config. Okay, but I want to change the IP address as this one. Okay, so let us check. So bash, and the machine name I want to give it to master, and IP 192.168.1.201. I want to give this IP to this machine, and I'm rebooting the machine. The machine is loading. Okay, so let me log in the machine using root user. So I logged in. Now let me check IP addresses. Okay, so whatever the IP in the document, I have changed it. And also you can just execute hostname -f. So that is master.hadoop.com. So that is fully qualified domain, FQDN I can say. And hostname, and roles in the storage layer and roles in the processing layer are defined already. Name node, data node, secondary name node in storage layer, and when coming to the processing layer, job tracker, task tracker. So it means all 2 plus 3, 5 Hadoop services I will install in this single machine. Machine name is master. Okay, let us see. So these are the tarball location and all. Okay, but copy and paste will not work in here. We cannot copy and paste. So how can we do that? So we can connect through putty, the same IP, then we can do the operations. 192.168.1.201. So I'll connected root, same password. So you can see we can do the operations here. Okay, so let us go back to the document. So now we discussed this first one, IP address and all. Now we need to download some tarball. Okay, so on this machine, all the Hadoop softwares, supporting softwares, what we discussed in the previous slides, have been already installed in this machine. This machine, master machine, all the supporting softwares, Java, everything installed. Now I will show it only Hadoop installation here. Okay, so let us see. Okay, so now here is a tarball location Hadoop software. Now I am going to install Hadoop 1.2.0. Okay, which is, we can, if it is not downloaded, we can download it from this path, but it's already downloaded and it is available in this location. Okay, in the machine /var ww. Let me show it. ls-la. You can see there is a Hadoop 1.2.0 software available. Okay, this is the line already available. Okay, let me come back and clear the screen, and we'll start the installation for first. So passwordless SSH, configuring passwordless SSH in the cluster. Okay, Hadoop cluster. Just copy and paste it. It will generate a key, authorized key in here, .ssh authorized keys folder. Okay, .ssh folder. So let us, next step is, so download the tarball. So we have already downloaded and put it in this path. From here we'll move it to C user local path. We have to move it. Okay, first, if any Hadoop folder already, let me unlink it, and if any folder Hadoop 1.2.0, let me remove it. Okay, and I am copying from this machine where www.html Hadoop tools, the Hadoop bundle is available, Hadoop tarball. From there I am copying it to user local. You can just check it, it will extract. Right, it is extracted, and let us execute, put a link to user local Hadoop. Okay, create a link and then provide the change owner of the Hadoop folder, HDP user, HDP admin. Okay, and just try the link. See, user Hadoop local is pointed to Hadoop user local Hadoop 1.2.0. Okay, so we have downloaded the tar file, and also the steps here, so you can install using this directly through the website also. Yum install, it will download it like using RPM's repository. Okay, right, and then if it is already available, you can download it from the copy. Okay, and setting up home path, step 3. So let me step it, check this path. There is some file is available, there is some configuration. So we need to set up this home path, Hadoop home java _ home path setting, which is already available here in this machine. Okay, so okay, I'll come out, saving and quitting and quit out, and let us open Hadoop environment setup file. So configuration file we have seen, hadoop-env.sh. So open this file, go to down slash and add this property, Java export path property. Okay, just add it, save and exit. Okay, and next one is core site.xml. After the Hadoop environment, core site.xml. Just open the file and provide Hadoop URL path here. Hadoop URL. Okay, so the machine name is like master.hadoop.com, right? So we can give the Hadoop URL here. And another next is hrefs-site.xml, right? So let me open this one. So here we can give all our Hadoop configuration settings. Okay, so I'm taking some configuration here. So replication by default 3, but we have only one data node, right? So I have given replication factor 1 only. If you copy any data, it will be replication copy only 1, not 3, since we have only one data node, right? So I have given replication factor 1. And let me copy this also, configuration files. So I need to create these disks and add again. So anyway I have opened this one, hrefs-site.xml. I copied here, and disk 2 also. So I copied 4 properties. Okay, and let me go up. So let me add it, slaves file. Slaves, we need to provide data node name, right? Data node IP address. What is the data node IP? 192.168.1.201, right? I have added. And let us create some directories, log directories. Okay, create log directories, sudo source etc profile, and I'm creating sudo mkdir user local Hadoop the log directory and changing the permissions. Okay, full permissions, so any user can able to execute a program and the logs will be rotated. Okay, it is done. And so you can see fs edits and log files are located in this below paths. Okay, so if we want to change these directories, we can create some folders, disks. Okay, one moment. Okay, right, so the above directory shows hrefs, fs image, data, edits will be available. So if you don't want to store it a temp Hadoop HTTP user, so you can create a disk. So let us create a disk 1 for names and edits. Okay, let us execute, right, and change the owner also, HTTP user, HTTP admin for /mnt. Okay, and this properties we added already, right? And also same block directory, we can create one more disk 2, right, and change the properties as well. Okay, and also we added this property also, right? And we have one more MapReduce processing layer, MapReduce configuration file, and open it, add the below properties. So MapReduce job tracker URL, right? So job tracker URL. So I have added, and we have done the configurations as of now. First one is we downloaded the Hadoop and we created a machine. We downloaded the Hadoop. We have configured the properties. Now the next step is, what is the next step? So format the name node. Format the Hadoop name node one-time activity. Okay, so let us format it, name node, using this command, Hadoop space name node hyphen format command. So any file system is available already in this machine, this Linux machine. It will ask if any file system is available, it will ask. So it is asking, you have already some file system available, you want to format? Yes. You can see there is a MNT disk 1 has been successfully formatted. Storage for what is it will store? Metadata. right? That has been formatted already. Now start the name node using this command. Hadoop daemon.sh start space name node is the command to start name node, right? So name node started. How to check whether the name node is started or not? Simple JPS command. You can see name node is running on this port, right? PID, process ID with name node. Okay, the same one you can start data node using same command. Hadoop daemon.sh start data node. Okay, starting data node. Again execute JPS command. Then you can see both name node, data node running, right? And also start with secondary name node, right? Start with secondary name node. Started. Check the JPS command if all three services are running or not. You see secondary name node, data node. So every service is, all three services are Hadoop services running, right? Okay, then the next one, what is the other services for the processing layer? So we have processing layer, right? Processing layer also, let me check. So in the down we have Hadoop daemon.sh start job tracker. Processing layer I am starting. Okay, job tracker. It is started. Again check with task tracker. Start. Right? So let me clear and running the JPS command. Let us see, observe it. All the services running on Hadoop cluster. What are the services? First name node, data node, secondary name node. These are related to storage layer, and job tracker and task tracker are related to processing layer. All services are running currently, Hadoop services. Okay, then Hadoop FSCK. So if you want to check Hadoop services, Hadoop commands, so you need to start with Hadoop. Hadoop FSCK, file system check. Execute this command. It will show the, if any files are available in Hadoop, it will show the list and the file status it will show. You can see FSCK started, file system check started by root from so and so IP address, path. This is root path is like distributed file system path in Hadoop. Okay, and also status is healthy, total size 4 bytes, total directories 5, right? And total files, 1 file is available. And you can see replication factor 1 for this cluster. Okay, and total blocks validated, 1 block is available. So minimum replication block 1. Some details are available, under replication, miss replication 0. So we have not copied any data. Okay, then one more command, Hadoop fs-ls, to see the files available in Hadoop distributed file system. So only one directory, temp directory available, that's it. That is pointing as 1 copy of 1 block it is showing, temp directory. Okay, let us. So we'll create some sample data in here. ls-la, this is local file system in Linux file system on this machine. This master virtual machine, ls-la, stands for local virtual machine. Okay, then we'll create some data. Since we have not connected any of the outside systems here, right? So generally, how you will copy data into Hadoop? from outside generally, but we don't have any other systems connected. So we have only one source. We can create some sample file here, some with data in Linux file system, and we can copy it from here to Hadoop. Okay, let us see. Sudo vi, I'm creating some sample file. So I have opened a sample file, but we need some data. So let us copy some data from internet. Open any one of the website, some Bangalore information history. I'll open some Bangalore history website, right? So we need some data. So this complete data, I am selecting all, copy, and I am pasting it here. Twice, thrice I'll paste it. Since we need some amount of space of amount of data required, right? So I'm pasting multiple times. Same data I'm pasting. Okay, exit. Save and exit. Now let us see ls-la. So we have a sample file created today, May 10th. See this much size of this file, maybe 3 MB or 4 MB something, right? So we have created one sample file, right? But we need to create some more files. So using cat command, we can create another file using existing file. Okay, so cat, I'm using cat command. So I'm taking sample file again. Sample file we have created, cat sample greater than sample1. It means using cat command, I'll create sample1 file from sample file. Whatever the data available in sample, I'll create a sample1 file. Created ls-la. You can see two files, sample1, right? Now same you can create using sample1, you'll create a sample2 file. Done. Now let us create one more file like using sample1, sample2. So we'll create a sample3 file. Created ls-la. So we have total 4 files available. Okay, so we'll copy one by one file from here. Here, what is here? Linux file system. So we'll copy one by one file from Linux to Hadoop. Okay, so before that, so we have web UI. We can enable web UI. We can see the Hadoop cluster status in web UI. Okay, so let me open a new fresh window and let me change the IP address here, not 151.201, right? I'm opening name node web UI. This is called Hadoop Onyx web UI. Okay, so I have opened Hadoop Onyx web UI. Now you can see only one block is available, right? Only one block. Live nodes, one data node, only one cluster, single node cluster, right? One data node. Okay, so now let us copy some data. Currently you see only one block it is showing, right? Only one block as of now. One block is each and every folder, it will consider as a block in Hadoop. Whatever the folder files, it will be considering as blocks. Okay, then now let us go to terminal and copy sample file to Hadoop. So command is Hadoop fs-copy from local. What you want to copy? Sample file. To where? Root. Root means distributed file system, Hadoop directory, Hadoop file system. So let me copy it. Yeah, file copied. Then go back to here, refresh. This will change it to 2. Observe it. See, 2 blocks. Earlier one block, now one block we copied, one file copied. So each and every file, it will be considering as a block, right? So if it is less than 64 MB block size, it is considering as a block. If it is more than 64 MB, then the file will be split into blocks. Okay, so we copied one file. Let us try to copy one more file, and we have a sample one, right? Right, copied. So let us refresh and check the blocks. 3 blocks total, right? Let us try to copy another second file also. Copied. So let us refresh and observe the blocks will increase here. 4 blocks, 13 total files, right? The same one, this is Hadoop directory. Okay, then copy last file, file 3. Yeah, copied. Total 4 files we have copied, right? 4 files means 5 blocks it is showing. Okay, 5 blocks. So these blocks are having some data. Whatever data is available, we copied from the internet, from Bangalore history something. We copied, right? This data available on that files. Okay. Now let us check what is the document. So we copied some file. We copied some, created some files, and we copied some data. Okay. Now let us check. Go back to here and check the Hadoop operations. So Hadoop FSCK, enter. You can see earlier only 1 block, now 5 blocks. Block replication 1, average block replication 1.0, right? Number of data nodes 1, number of racks 4, 1. This is the way where we can create some data in local path and load it for testing purpose. Okay, in Hadoop. Okay, now let us see files. Whatever we copied the files, how can we see? To see the files in Hadoop directory, Hadoop fs-ls / enter. So it will display what are the files we copied: sample, sample1, sample2, sample3. 3 files we just copied it from local file system to Hadoop, right? Okay, then let us see. So we have some Hadoop fsck file system check. So we have some commands we have seen in here, right? fsck files will execute one by one. Hadoop fsck / first command. So it is displayed 5 blocks, file system is healthy, right? Now let us clear. Hadoop fsck -files. I want to see only files. What are the files available in our Hadoop? See, these are the files, 4 files: sample, sample1, sample2, sample3, with size and bytes. How many blocks that file has been stored? 1 block, right? So total 4 blocks it is showing, right? Then let us check other command, files blocks. Files -blocks. Block name also I want to display. You can see file displayed already, file name sample, and also that file has been divided into 1 block. The block name is like this is the one, and length of the block, replication factor. This is what where we want to show. We have copied, right? That's what it is showing. File 1, sample file is 1 block. and block name, block number, something. Right? And let us see another command. Files, blocks, locations also. Let us clear files, blocks, hyphen, locations. So locations means which data node it is stored. Okay, let us see file name, one block, okay, and also down block name, some replication one, and also where it is stored, node details. Where it is stored, where we have stored in here 192.168.1.201. This node I want to store it, right? Store it. Then the next command is locations racks. How many racks we have, general something that we can see it later. Racks technology and all. I am executing racks. So default rack, you see, rack is default rack. Default rack with one IP addresses 201. That is the where here it has been storing. Then the next one, what are the other operations? So we can run Hadoop admin command like Hadoop dfs admin hyphen report. So this machine details will get it here. See, configured capacity, present capacity, distributed file system remaining space available, distributed used, current one used 933 KB only, DFS used percentage, under replicated blocks if any, blocks with corrupted replication if any, missing blocks if any. So these are the information where we can search it as per Hadoop admin command. And also that is name node. So this is down one is data node. You can see data node name, available one replication factor, right? Decommission state, normal, configured capacity 22100359 something, and distributed file system used, how much percentage used. Now I want to shrink it to other database. Okay? So this is the what where we can see it here. Okay, then what is the next one? Okay, so let us now, as of now, we have seen storage layer only. So we have not seen processing layer, right? Let us see processing layer and execute one sample programs. Okay, but before going to that, let me open the processing layer URL. So it means we have opened here name node administrator, right? This is storage layer. So same way I want to open processing layer. Okay, let us check. So I'll open processing layer, but IP will change it 201. You see, map reduce layer. It has been loaded map reduce layer URL, right? Where it is, how many jobs submitted, we can see it here. Running tasks, submitted tasks, total submissions, if any, all the details we can see it here. Right? Okay. So now you can see, for example, if any scheduled jobs, it will show it here. Scheduling information. And if any current jobs running, currently running jobs, it will display here. Retired jobs, if any, it will display to there. And local groups, local logs. Okay. Okay, so we'll try to execute one sample job with word count of sample file, and then we'll try to see here. Okay, so example of word count, some command is available already. Let me close it. Okay, so let me close this one, notepad. Okay, so I'm putting, okay, we can see it here. So user local Hadoop, there is a Hadoop sample jar file is available. Hadoop hyphen example hyphen 1.2.0 jar file. Using this jar, we'll execute of word count of sample file. That is our job. So where it will be storing the output in an output directory. Okay, let me execute. So let us check it. Right, it is starting. So running a job, go to here, just refresh page. You see one job submitted, right, but still not started the job. If job is started, it will show running jobs. Right, now you can see job is started, priority normal, user root, name of the file, word count, and some capacity. 100% completed for the word count. And go back to the terminal, you can see it here. First mapper is executing 100%, then reducers still 0, 100% completed reducer. You can go back to here, refresh, both will complete 100%. Okay, then you can see job is successfully executed, right, job completed, and below are the counters. Here you can see the counters. What is the counters? What time the job is executed, and what was the memory it required to execute a job, permissions. So all the details you can get it. Especially for Sunnyvale, you need to get it. Right? So we can get it all the log files using job counters, everything here. Okay, so we can verify how the job is executed, what was the memory reduced, and reduced input groups, combined groups, total compiled heap memory for execution of this job. So everything we can get it here in counters part. This is useful channel. If a problem got failed, for example, if a job is failed, so we can verify using these counters. What was the problem? Why it has been job has been failed? What is the reason? So we can troubleshooting the job. Okay, so so now we have executed the job. Okay, so let us go back to the UI and check, refresh. So once the job is completed, the job will move to completed jobs, right? And you can open the jobs, open the job, and then check all the information details available. And also you can see mapper reducers output also. Okay, so we'll see the output in command line. Some graphs, some charts also they have written, right? So the output of what was the program we have executed? Sample file, word count. How many words are there for each word? How many times available each word? So that is our job we have executed. Okay, now let us execute Hadoop fs-ls / and when we are executing a job, we told that we'll create a output directory. So it has been created output directory, right? Now let us cat that command, cat that file. Remove one /. You see, there is a 3 folders created inside. One is output _ success, output /_ logs, output slash part hyphen r dot 00000. There is a number. This is the where we have output of above program we have executed. This I want to open. Okay, let us open cat. To open a file, cat command, right? So I'm just copy and paste it and execute. See, the file, whatever the file we have taken, sample file, this many words, this many times are available. For example, supply word 6 times, non-profit word 6 times, and facilities word 12 times available in the file. So this is where we can check it and we can execute some jobs, sample jobs. Okay, but our duty is, admin duty is like, we are not going to write any coding. So we are just monitor. If any job is user asked to execute a job, we can monitor it, we can execute it. And also configuration files we need to create it. So based on the cluster connectivity and everything, that is a big challenging job for every time, everywhere. So we are not sure what are the configuration they have given. So that is the scenarios. It's very difficult to configure. So you need to find it some basic troubleshooting steps, skills in website, and then go through that once. Basic troubleshooting, how it will be done. Okay, right. So let us, these are the log file, output file. Okay, so now what is our task? So now another task is like, so we have installed Hadoop on X single node cluster, and we have copied some data from outside to Hadoop, right? And also we have executed some sample job as well. What is the job name? Word count. We have executed successfully. Okay, then let us go back to here, refresh and see. At the same time, let us refresh here also. 14 blocks. So now we have executed some program, right? That program, it is generated 3344 outputs. That output, every output is considering as a block, right? So that was 14 blocks are created. Okay, let us check further what is the other options, other operations we can do it in here in Hadoop single node cluster. Okay, okay, so we copied some data into cluster, right? That cluster, how to check in web UI the data. So you can go to here, browse the file system, copy this IP. Sometimes it will load into name. So that name you can change it with IP, and this will work. So these are the data we copied, right? So sample 1, sample 2, sample 3. These are the data. Let me open the data. If it is still pointing, not pointing, just to replace IP. Yeah, this is the data we have copied from internet, right? Bangalore history. That is the where we downloaded, we copied, and we pasted into Hadoop file, created a sample file, right? So this is what sample file created. Sample file creation and loaded into Hadoop, the Hadoop distributed file system, run a sample job, executing a sample job and get the result, and to check the result. This is what we are doing here. Okay, then let me check the remaining, what are the operations we have. Okay, so let us some more theory part for 10 minutes. Let us see. So how to check HDFS services? This we have checked already just now, all the operations, HDFS, FSCK, FSCK files, FSCK blocks, all options we have checked, right? And also as a Hadoop admin, So we can run the HDFS Hadoop FSCK command on regular intervals. If any corrupted blocks, it will fix the issue. That is the Hadoop admin job. Okay, right. The next one, data dealing with data corruption. What is the corruption? Data dealing with data corruption. It is setting up a trash in Linux or Hadoop, and in general our scenario Windows, we can call it as recycle bin. Okay, so this is similar to recycle bin in Windows. Its purpose is to prevent from unintentionally deleting the data from HDFS. Value is minutes. Okay, so where we are going to mention this setting up trash folder in folder property in CoreSite.xml. So with value, by default 6 hours it will be maintaining on the data even if you delete it, right? So that is what. And one more is to Hadoop remove hyphen skip trash. So you don't want to move the file when you delete a file, you don't want to move to trash. So using skip trash command, we can permanently delete the data. And also permanently means it is instead of moving, it will be directly .trash file moving, right? And so permanently delete means, so you want to delete it from the trash also. Hadoop fs-expung is a command. So it will delete completely on the .trash directory also. Okay, clear? Right. So let us not go back to here. So this will take it a separate class. So let me, okay, then we'll discuss the space reclamation. Okay, let us wait. So when a file is deleted by user or an application, it is immediately moved to the trash directory in Hadoop. So for example, if one of the user deleted a file, so it will immediately move to the trash directory. So each user has its own trash directory. For example, in generally Hadoop, we'll create a users, right? General users, create a new users. When you create a new users, if the trash property is enabled by default, it is disabled. So if you enabled, when you create a new user, automatically in the user directory, there is a .trash folder will create. Okay, and the file can be restored as quickly as long it remains the trash. So for example, if you delete a file by mistake, if you want to reload the file from .trash to your directory again, so you can do that. If it is enabled, so it will be available next 6 hours. If you delete a file now, it will be available in trash.trash next 6 hours. After that, it will delete permanently. Okay, right? And after the expiry of its file in trash, the name node deletes the file from the HDFS namespace. So after the expiry of its file in trash, the name node deletes the file from HDFS namespace. Otherwise, again, it will be a conflict. So trash feature is disabled by default. So we need to enable it. So user can enable this feature by setting a value greater than 0 for parameter. So fs.trash.interval in CoreSite.xml, we need to configure it. Okay? And also user can configure an appropriate time to tell name node how often to create checkpointing in trash. So where the property fs.trash.checkpoint.interval in core-site.xml. This value should be similar or equal to the fs.trash.interval property. Okay, right? So let us move it. Block catching. What is meant by block catching? So normally data node reads blocks from the disks, but for the frequently accessing files, the blocks may be explicitly cached. The data node's memory. Block cache. By default, a block is cached in only one data node's memory. Although the number is configured on per file basis, job schedulers for MapReduce, Spark and other framework can take advantage of cached blocks by running tasks on a data nodes where blocks are cached for increasing read performance. Okay, right? And also data node failure, heartbeat, re-replication. When it will be occurred, what are the scenarios? So each data node send a heartbeat to the name node periodically, right? We discussed already. A network partition can cause a data node to lose its connectivity. For example, so if any of the situation, any of the network issue, data name node is unable to connect data node through name node, right? That time also the name node detects this condition is by absence of the heartbeat mechanism. The name node mark that node as a data node as a without recent heartbeats will be considering as a dead. It means name node will consider that data node has been dead already. Okay, and it does not forward any input output processing request to that node, right? And any data that presents in data node is not available in HDFS anymore. So any data, for example, if a data node is failed, it means some problem, it has been down. So if it is down means we cannot get that copy. One copy will be available in that data node, right? So that data node copy will not be available into Hadoop anymore. So data node death may cause the replication factor of some blocks fail below their specified value. For example, if you created a file with 3 replication factor, one data node goes down, so you will lose one copy of the data. So it means we have only 2 copies, remaining 1 copy missed. If it is by default 3 means, right? That is where we have to verify it. The name node constantly tracks and we need to verify, that's it. So we should not take any more action is required. Any more action is not required from our end, since name node will take care of everything. What from our end, we need to be patiently wait. That's it. Okay. So when re-replication will occur? So whenever, what are the scenarios? Block re-replication will occur. So data node may become unavailability for certain amount of time. Replication may become corrupted. So one of the replica has been corrupted that time, and hard disk on a data node may fail, and replication factor of a file may be increased. So these are the scenarios where we can consider, okay, all the re-replication will occur, right? Another, when data node marked as failed. So when it will be data node marked as a failed node. So data node send heartbeats for every 3 seconds by default to name node. So due to some network issues, name node may miss sending heartbeat for every 3 seconds. So name node will check below parameters to make sure data node is failed. So what is the property? DFS dot heartbeat dot interval equal to 3. So name node will wait for 10 seconds, 10 iterations and 30 seconds. So if still the data node is not up, so it means it is considering that data node is a dead node. So that data will not be available to the name node anymore. Okay, right? And that will be marked as a dead node. So let us check. Okay, so we have 5 more minutes, right? And what is the next one? Okay, and also we have cluster here, right? We have installed the cluster. So one more, so before early started, when we are going to start the services, we have started manually one by one services, right? So now stopping also, we have one more option, stop -all.sh is a command where we can stop all the cluster services, currently running services. So name node, job tracker, task tracker. First it will stop storage layer, then it will move to processing layer. Sorry, first processing layer, then it will move to storage layer. Right? So stopping data node, task tracker, job tracker, then stopping name node, stopping data node, stopping secondary name node. We have stopped all the services. Like earlier starting, we have started each and every service separately. Like Hadoop -daemon.sh start name node, start data node. But now I want to start a single shot all the services. Command is start -all.sh. Simple command. So it will execute one by one all the Hadoop services. Yeah, let us see. Okay, then click on JPS. You can see services, all services are started. Right? This is where we can start the Hadoop cluster, Hadoop services. Okay, so I have done for this session. So we have done the Hadoop single node cluster installation, and I am going to stop the services. So till now we have seen Hadoop 1x cluster installation, right? So let us stopping all the services, and then we can close this Linux machine. Okay, so I am exiting, and I am going to exit this also. Machine whatever we started, virtual machine, right? Then I'll close this also, whatever we opened, storage layer, processing layer, right? And this is a document where we have installed the Hadoop 1x, right? Okay, further next one we can see further session. So Hadoop cluster rebalancing concepts. So further we'll see on the next session.